let's see about this problem. Okay, we've got, loads on it. Again, they're termed service loads. That means unfactored. Got a dead load, 1 kip per foot, live load, 1 kip per foot. With service loads, again, the general load combination that's going to control with just common amounts of dead and live is going to be, the dead load multiplied by 1.2. So that's 1.2 kips per foot factored. And the live load factor is 1.6. Again, in this case, times 1 kip per foot. Okay, so total factored load on here is 2.8 kips per foot. All right. Now again, uniformly loaded beam, 2.8 kips per foot. Not going to go all the way back to statics. But if you do need a refresher, I'd go back to statics, chapter 3 in the book. Beam reactions, go through and do it. You are going to be responsible for that. And not every case is going to be this case. Okay, so again, know how to do reactions, beam reactions. In this case, you're going to come up with a reaction equivalent on both sides of 28 kips. Right? Correct? Okay. Shear diagram starts out at 0. The reaction pushes it up to 28 kips. Then the uniform load drops it down.
That's 28 or 228?
The reaction's 28. Okay. The load, factored load, is 2.8. So you're dropping down now 2.8 kips per foot. That means you cross 0 out here in the middle of the beam, but then you keep on going down, actually 28 more kips, so you're down at negative 28, and then the reaction on the right side pushes you back up to 0. Okay? How could I tell that this crossed out 0 out at the middle? 28 divided by 2.8 kips per foot. 28 kips divided by 2.8 kips per foot, 10 feet. All right? Your moment diagram goes down below the shear diagram. All you want to do is really calculate different pieces of area that you have. This is a triangle. 1/2 base times height. 1/2 10 feet times 28 kips. It's a positive area. It's above 0. That would give me an area that would be a positive 140. And again, look at the units. Foot, kips. That's the units you should have for moment, right? The other area, 1/2 times base, 10 feet, times a negative 28. Hey, lo and behold, that comes out to be a negative 140. So, my moment diagram starts at 0, goes up to a maximum value of 140 foot kips. And then it decreases down to 0. In concrete design and evaluation, we would call that 140 foot kips, we call that MU. If I took that beam that we just had in our previous example, and I'd ask you the question, does that beam, would it work in this case? What would you say? Why? Okay, you'd say, if I asked you that question, hey, would the beam in the previous example work in this scenario? You'd say, yes, because Vmn, the design moment capacity of my beam, is greater than the required or the factored moment on the beam. I think your Vmn was what, 190.5 foot kips? And that is greater than or equal to 140 foot kips. So you'd say, yeah, it would work. Now again, that's very fundamental evaluation. I mean, there'd be other things to consider, but for that, for bending moment, you'd say, yes, it works.
You accept just how lowering costs, therefore okay. Like after you make that statement to bottom, 190.5,
Oh yeah, that's fine. I mean, I assume that you know that, but if you want to write it out, that's good.
Well,
That's good.
Photowork will take off.
That's good. That's good. Okay. So questions on that? You sort of see how this is working?
Did you get the 28 feet is 2.8 times half the length?
To get the 28 kips,
Correct.
yes. But if you're asking that question, I'd tell you to go back to chapter 3. Because again, if you are going to assume that every test problem, every homework problem is going to be this, you're wrong. So if you're in any way, shape, or form, hesitant about, that. I mean, this is the most base level, type of problem you can get. So don't be, and reactions is the key starting point. If you don't get reactions right, you're done. Okay, so if you need to go back to reactions, go back to statics, go back to chapter 3, review it. I mean, there's 6 example problems in chapter 3. You just review those and you'd say, oh yeah, okay. If I'm given something different, I'll know how to do it.